Probably not before the end of the school year, though. Okay. Declares and manipulates the values of some variables of various types, albeit new ones intended for use in developing GUIs. There is, however, just one big issue, which is that not just your program, but an end user can spontaneously change the state of any active user interface widget, move a slider, scroll a document. How does your program know when the user has attempted to do so? So there's actually a lot of problems with graphic user interfaces as opposed to just text-based user interfaces. One of the main ones is that you have a bunch of components. So the example we'll talk about today is just a very simple graphic user interface with a bunch of buttons, like a reset button or a copy button. And what it's going to do is it's going to take any text that you have on the top, say hello, and when you press the copy button, it's going to copy it to the bottom. It seems very simple. However, there's a lot of things that go into this. So how do you know when the copy button has been pressed? How do you know that when the copy button has been pressed, it is the copy button that has been pressed instead of the reset button? How do you know what to do when the copy button has been pressed? How do you know how to interact with the other components of the function? Because when you press the copy button, you not only have to worry about what the copy button is supposed to do, but what components is it supposed to draw from? What components is it supposed to post to? Lots of things to worry about, essentially. How does your program know when the user has attempted to do something with a widget? And that's what we're going to be talking about today. The main form of user interaction, like I said, that we've been using so far is the simple reader, and that's fine and dandy, but there are lots of other input devices that you might have, like a computer mouse or a Kinect controller, so on and so forth. Okay, terminology time. When we're talking about specific like components within a graphical user interface, we use the word widget. So a widget is just something that exists on the screen. So this copy button is a widget. This reset button is a widget. This text panel is a widget. And this text panel is a widget. We said that the act of somebody manipulating a widget is called an event for that widget. So when you click on the scroll pane so that you can start typing, that's an event for that widget. When you press the copy button, would be an event. When you hit the reset button, that is an event. All of these things have to have predefined functions or things that happen when you press those buttons. So you need to know when the copy button is pressed, what should happen? When the reset button is pressed, what should happen? How should it respond to that event? The widget that the user has manipulated is called the subject of the interaction. Oh my gosh. Okay. I started recording, but I forgot to share my screen. Okay, now we're good. Okay. And then the objects in your program that need to do something in response to the events for a particular subject are called observers or listeners for that subject. So it's not entirely up to these widgets to respond to everything. You'll see that we have other components that do that. Most notably, we have things that are called listeners. The listeners are going to be an object which point towards specific widgets. So let's say we have a listener that will post towards every single component on the screen and will listen to those widgets and essentially wait for something to happen. So once you start the program, the listener's entire job is to sit there and wait. And as soon as the copy button has been pressed, you'll see that the copy button actually has a reference back to the listener. And the copy button will go to the listener and say, hey, somebody pressed me. It's time to start doing things. And then the listener can act accordingly. Okay, so how do we set up these listeners? Well, the first solution is to use something called polling, which is that the main program acts as the only observer. So that's what would happen here. And it continuously polls all of the widgets on the screen every single second or every single microsecond or as fast as it can go, and continually polls them and says, hey, has something happened to you? Hey, has something happened to you? Hey, has something happened to you? Over and over and over again, thousands of times a second, until something happens, in which case it can respond. You might think that is a highly inefficient way of doing things, and you would be correct, because imagine if, say, like, I don't know, what's like an app, like Twitter did this, and it was just polling thousands and thousands and millions of components on your screen over and over again to ask if it's been changed or modified or pressed. It would be very inefficient. Here's how you could implement that if you wanted to. While true, if S0 or subject 0 hasn't experienced an event, you have to respond to the different types of events that it could be. Then you have to check if S1 has experienced an event. And if S1 has experienced an event, second subject, say the reset button, you have to process all the events that could have happened to it over and over and over again, thousands or millions of times throughout the program's runtime, which is bad, very bad. Do not do this. Second solution, one that's a little bit better, is using callbacks. So each observer, and you can set up multiple observers for multiple different subjects in your program, registers its interest in a subject's events, and then waits until the subject calls it back. So this is kind of like an email list where an observer will subscribe to, say, the reset button and says, hey, man, I'm not really going to like check in on you too much, but if something ever happens, please come tell me. And so the reset button sits there and it waits. And finally, its shining moment comes and the user presses the reset button to, say, clear the input window. And it says, hey, wait, I have to go tell the observer. The observer registered interest in me. I need to go tell it that I've been pressed. So the reset button metaphorically goes to the observer. It says, hey, I've been pressed. It's time for you to do something. And the observer will then carry out the action of clearing it. So how does this work? What does this mean? This is known as the observer pattern. It's one of the patterns that we'll be talking about. The other is the model view controller, or MVC. But this is the first one that we'll talk about. Each subject or each widget on the screen registers each or expects each observer or listener to register itself with that subject if it is interested in the subject's events. And then each subject keeps track of its set of interested observers. So the reset button might have multiple observers, all of which are have registered interest in the reset button. And then when the reset button has been pressed, it goes to the list of all of the observers that have registered intent with it or interest with it. And it tells them, hey, I've been pressed. I don't really know what that means. I just know that it has happened to me. You should deal with the fact that I've just been pressed. And the observers will do so. Whenever an event occurs, the subject invokes a specific callback method for each registered observer, passing an event argument that describes the event. So the event could be like, has been left-clicked, has been right-clicked, in case you wanted to have separate functionality for if the reset button was left-clicked or right-clicked. It'll say, hey, I've been pressed with event E, where E just represents an object of an event type, which is exactly the same as any other Java type that we've talked about before, except it has its own properties. So events are a class in Java, and they have properties. I'm going to say, hey, I've been pressed. The event was left click. And then each of the observers will have something to do with that information. Registering interest is done by calling a method of the subject. Usually this is done once as part of the setup. So we'll actually dive into some code today for how this is set up, and you will see exactly how it works. But usually when the program begins, all of the subjects are registered with certain observers. Okay. The set of observers for a given subject can be kept in a set, for example, instead of an array or a queue. And it'll just pop off all of the observers and tell it, hey, this is what has happened to me. Go have fun with whatever that was. The callback method is described in an interface that any potential observer must implement. So we are going to have a class diagram, way more interesting, well, because it's not just the same one over and over again. And you'll see that. This is known as an object-oriented design pattern that addresses common object-oriented programming issues, often language deficiencies. Most are considered best practices. So I know at least in 3902, you will talk about other design patterns, maybe in 3901, but they're essentially just ways of thinking about code that are not necessarily baked into the programming language, but can be carried out within the programming language. So Java doesn't necessarily have implementations for observer patterns or GUIs. They are packages that have been built by somebody way smarter than me and licensed for us to use. It's the Swing framework. Stuff like arrays or primitive types are built in or baked into the language. Design patterns usually are not. They're more of ways of thinking about code. Okay, and then here is the class diagram that I said was way more interesting, which is you have an interface called action listener. And since it's an interface, we know that it does not describe functionality. It simply describes how a certain class that implements it should be able to operate. So the action listener has a method which allows any subject or any class that implements it to essentially describe what should happen upon an action. And that's what this demo GUI does. And then the demo GUI extends the JFrame class. These are both components from Java's Swing framework, so they're already defined for you. And then we just extend or implement them with the demo GUI class, which is the main class of the code that we're going to be talking about today. This class is a type of the main window of a GUI application. So a JFrame is just a class that describes just a frame on the computer. And you'll see what that looks like. It looks like any other program. The interface action listener declares the callback method action performed, which is just a method which defines how a subject should respond to things. So on action performed, it should do something. And then pass in the event argument E. This class, or our code, the stuff that we're going to actually implement, contains the body of action performed method based on the program's intent and the other code to set up the GUI. So our job is going to be setting up the graphical user interface, registering the observers, setting up the design pattern, and then implementing what should actually happen when certain widgets are pressed or certain things happen to the code. Okay. Here is the interface as it looks. It's interface action listener, and it has this singular method. The contract is not shown here, but it's called action performed, and it has this class called action event E. So it takes in an action event E. An action event E is just another class that is similar to any other class that we've written and just describes things that might happen. So left click, right click, click on text window, scroll, all the things that can happen to a widget that you have placed in the GUI. It has this object get source. So the interface is actually described somewhere else. This is just showing it here for simplicity's sake, I guess. But we have this interface action event, and the object contains an object called get source. Get source just tells you what is the source of the action event that we have been processing. So the object class is special. Every class except extends object, which we'll get back to later. Okay, here's the interesting stuff, which is actually what the demo GUI application looks like. So I drew a picture of it earlier, but it was crude. At the base level, JUnit, or not JUnit, JFrames and Java Swing applications are contained within windows, and then you add components to those windows. So this JFrame is sort of the high-level frame of a graphical user interface that you've defined, and then contained within that frame, you can have a bunch of other things. So you have a JText area on the top, a JScroll pane on the bottom. These are built-in things that you don't have to program, but that you can just call and create, and they create graphical components on the screen, nested in the JFrame. So this one is actually, it goes a little bit deeper than that. So we have a JFrame, and then within that, we have a component which stores 3 rows of information. So we have something that will store 3 rows of information. And then we say that top row should contain a JText area. We say that middle row should contain 2 columns in a JPanel, which is what this is called. So this JFrame contains a JPanel, which has 3 rows. That's this. And then we're saying the top row of that JPanel should be a text area. We're saying that middle row of the JPanel should be another JPanel, which contains 2 columns of things. The leftmost one should be a J button, and the rightmost one should be a J button. So this J button contains 2 J buttons. And then the bottom should be a JText area. So it's a very hierarchical, even though it looks like it's only 4 components. Technically, you could draw it as if it were a tree, right? So you have JFrame at the top, and then below that, you have your JPanel. The first child is a J text area. The second child is another J panel, where it has two children, which are both J buttons. And then the third child would just be a J scroll plane. So technically you can draw it as a tree. I don't think we do that, but considering it's a hierarchical data structure or it's a hierarchical thing, you could represent it using a tree. And that's really graphical user interfaces as like an overview. It's components within components within components, all contained within panels or flow areas to make it look actually nice. Later on, you'll make a calculator, which will be a bunch of J buttons within J panels, within different layouts to make it look good. Questions so far? Okay. So this is the underlying type of the main window of a GUI application using Swing is the J-frame. J-frame is the father of all components. Nested inside a J-frame's content pane, you can put any number of things. In this case, we're putting 3 J panels, and inside this one, another J panel. And inside a J panel, you can put any number of buttons. So if we wanted to, we could add a third button. If we really wanted to, called, I don't know, flip. Or would just flip the output and the input. You can also put in a J-frame a J scroll plane with a text area. Oh, so it actually is a little bit different. So this is a J scroll plane with a J text area inside of it. So the purpose of this is to allow you to scroll through the J text area. So components within components. This one differs from the top J scroll plane or top J text area, considering the fact that it's contained within a J scroll plane, meaning that you can scroll through it. Okay, let's see what this actually looks like. So we have this here, which is our demo GUI code. And if we run this, you will see we have, oh, well, it's on the other screen, but we have quite possibly the most interesting GUI application that has ever been created. What you can do is you can type on the top, hello world, and you can copy the input to the bottom. It's very awesome. And then you can reset, which will clear both things. And then if we have, say, bear with me here. We add a bunch of text. You will see that if you copy the input to the bottom, you can scroll through. And you can do it on the top too. So maybe they lied and that the top is also a J scroll plane. But then you hit clear and it resets both things. Very interesting application. It is one of 3, Demo GUI 1. There's 2 sequels, which are even more interesting. Okay, let's dig into what this code actually does. So we have the Demo GUI class, which is going back to that, shoot, let me find it. We go back to the class interface. Demo GUI extends the J-frame class. It implements the action listener. So this is just literally exactly what this is, but in textual form. And then during the main method, all we do is we set up a new demo GUI class. So we call it a constructor to the demo GUI. And we'll talk about how this happens later, but this sets in motion the entire process of registering the observers, creating the graphical user interface window, and then deploying it out so that the user can actually see it. Okay, we'll talk about the model variables, but the model variables for this are the string input and output. We talk about model view and controller next this Thursday, but as a little bit of a teaser, what is stored on the actual screen is not technically what is stored on the actual screen, if that makes any sense, which it doesn't. So let me explain further. What is displayed on the screen is different than the back end, which is what is the actual, okay. Better example is that what is shown to you is like a Java component, like int. In the back end is the mathematical model. Representative of something. In this case, the view, which is what you can actually see on the screen, is modeled by a model, which is what is actually stored in the backend. And it is the job of the controller, which we'll talk about next week, to essentially communicate between the model and the view to make sure that they're always in sync. The reason that we do this is because if you do everything in the view, it's quite difficult to do more complex things. So for the calculator app that you make, it would be quite difficult if, or you can actually just see the example on your calculator. Usually when you have like a calculator, 3, what will happen is you will hit the plus sign. Sometimes it'll disappear. Where did it go? It's being stored in the model. The model is essentially the ground truth of what the view is representing. So the model of the calculator will have, say, like the last few operations that you did. It will have what's stored in like the top, and then all of the buttons are modeled by models in the backend. It's quite confusing, but it's a lot easier to explain on Thursday when we get into demo GUI 2, and then we actually have the model and the view. But essentially, these so-called model variables in the model view controller terminology related to or confused by mathematical models as used in design by contract. So we will have an input and an output string, which are modeled by the view of the input and output. So technically, there's 4 strings. There is the view string of the input. There's the model string of the input. There's the view string of the output. There's the model string of the output. And it's up to the controller to make sure that they're always in line. Okay. Then we define a bunch of variables such as line in text areas, line lengths in text areas, rows in panel grid, columns in button panel grid. All of these simply define constants about what should exist about the GUI. So if we change any of these numbers, like for instance, if we say line lengths in text area is like 500, I don't know if this will break things, but we'll see. You'll see that, oh, juice. Oh, okay. Oh, God. Okay. You'll see that it's just very long now. And you can have a bunch of, the line lengths are now 500. So if you want to count, that's 500 characters that you can now put in. Awesome. We could change it back to, what is it, 50, 20? If we have, instead of 5, we put 500. I'm assuming this is just going to make a very long, uh-oh. Okay. Now it is just very long. You'll see that because it's so long, if we do the whole thing where you full screen it, it will just make it a JScroll plane because it's trying to fit 500 lines in that JText area. I think that's the only interesting thing we could do so far. If we add another row, actually, I don't know if they'll break things, but we'll see. No, it doesn't. You'll see that it's exactly the same, except we have another row down here at the bottom. But it has no components, so it's just blank there. If we have, change this to like, I don't know, 20. It's fun to play around with. Oh, I guess it doesn't. Column in button panel grid. So in this case, it didn't do anything. Yeah, so you can play around with this, change a bunch of the variables, and it will change things about the demo GUI 1. And then here are the components that we talked about before. We have a JText area, input text, a JText area, output text, and then 2 J buttons, the reset button and the copy button. Okay, and then here is the no argument constructor for the demo GUI class. So when we run this, this is the code that will get run, and we'll simply create all of the components that we just talked about. So we call super, which is just a way to go to the parent class and then call the constructor of that class. I don't think we might have talked about it, but what this does is it goes up to the JFrame class and then calls the constructor of the JFrame class. So I think we might be, yeah, okay. So this goes to the JFrame class and sets up a JFrame with just a string title. So we're just saying that the title should be simple GUI demo. If we change this, you'll see that when we run it, the title on the top has changed. Wild stuff. Then we set up the model variables. Initially, we have that the input and the output are just blank. If we change this to, say, text, when we run it, the controller will update that, and it should. It doesn't. Interesting. Maybe I didn't save it. It's not. Maybe something has to happen. No. Huh. Weird. Anyways, that should have probably changed the view, but it did not for reasons unknown. Anyways, moving on to the GUI widgets. These are the things that are actually going to get pressed or interacted with. So we say that the input text is a new JText area, which is just another class which has a string text, number of rows, and then number of columns. Oh, that's why it didn't do it, because it's not setting it equal to this. So if we change this controller or this, yeah, there we go. If we change the constructor for the buttons, you'll see it'll add hello world as there. This code's actually debunked. This should probably be this dot input, and this should be this dot output. I have to bring that up with Bucci. Okay, and then it has lines in text area, line lengths in text area. The reason that we do this is the reason that we don't have any magic numbers in programming languages is because if we want to change something about lines in text area or line lengths in text area, like we were doing before when we were just playing with the GUI, we can just do it directly from here, and we don't have to go through and dig through the code and find out where it's defined. And then we make the reset button, which, if you look at the constructor for that, just takes in a string, which is the text of the button. In this case, it's clear, and then copy input. Then we set a bunch of things about the JText area that would be useful. So set editable is true for the input text. Line wrap is true for the input text, and then set wrap style word is true for the input text. This just makes it so that you can edit it and that the lines are wrapping around. I don't know if there's a terminology for that. And then we make the input scroll plane and the output text scroll plane. Because if you remember, I guess in this case, it looks more like this, where we have, where's my chalk? Two J scroll planes. And then in that, we have a J text area. So that's what we're doing here. We're making scroll planes, and then inside of those scroll planes, we are putting a component. And what this does is it says, hey, any component that's in me, you should be able to scroll on it. Right. So that's why you can scroll on that. And then finally, we have a J panel. A J panel is just a panel which has a layout manager. We'll talk about different layout managers, but we're using, what's it called? The grid layout, which I guess you could just go here, which just has a number of rows and columns. There's also the flow manager, which just takes in any number of components and will just format it for you. But we're doing a grid layout, which is rows and then columns, and then we're stuffing that grid layout in a J panel. So technically, actually, something like this. Inside the J panel is a grid layout. And then sit inside of the grid layout is the two J buttons. Then to that button panel, we add the reset and the copy button, and it will be formatted in the grid layout because that's what we've defined. And then we set the top. Well, I guess I'm modifying it again, but in this J panel should go to another grid layout. It's gonna be like a recursive thing. This should be a grid layout, and then this should have. It's the world's best tree. Should have all the components within it. And then you can add the input, the button, and then the output. Okay, and then here's where we talked about before, all of the things that need action listeners. We say this dot reset button dot add action listener. This, technically this goes against, oh, well, no, it doesn't go against things because usually you don't want to pass in this as an argument that you're calling on this. But we're not calling it on this, we're calling it on the reset button. So we're saying, hey, take the reset button that is attached to this, reset it, where is it? Up here. They're J buttons, and then we're saying add this as an observer for all GUI events. So that this, which is the main program, will be the person who responds to all of the events. In future iterations of this demo GUI, we'll actually have a controller that's in charge of taking care of things, but just for this first one, we have the main application do everything. Then we pack it up, we set the default close operation to default close, and then we set visible to true. And that's the main constructor. That's what happens when we call new GUI up here, is it sets everything up, packs it, and then displays it nicely for the user. Okay, now we have the action performed, which we must override because it's an interface. And then what we do is we get the source of the action that was performed, and then based on what it was, in this case, either a reset or a copy, we have a bunch of implementations of what should happen. So if it's a reset button, it should just set the model variables to empty strings. Otherwise, it should get the text of the input and then set it equal to the output. That changes things in the model, but it doesn't change things in the actual output. This is what I mean when I say that you need to have synergy between the view and the model. So if we comment these codes out, or these lines of code out, you should see that when we run it, it will update what's going on in the backend, but it will not actually do anything to the front end, or it shouldn't. Yeah. So we're pressing the buttons, and it's updating this dot input and this dot output in the backend. I wonder if I can actually system print. So if we print out what the program actually views as the input and output, we should be able to see that it's doing stuff. It's just not displaying to the user, because what we're actually doing is modifying the model. And what we want to modify is the view. Or we want to modify both, but we want to make sure that they're in sync. So if we press clear, yeah. So you can see it's printing out the input and output, but it's not updating it because we've commented out the line of code that sets the text of the view component to the text of the model component. So input text and output text are two things, and then input and output are two other things. These are the models on which the views are, I guess, predicated. I don't know if I'm using that word right. And then finally, we set the default cursor to cursor.getDefaultCursor. And that's what happens every single time that a button is pressed. It will call this action performed. It'll pass in what action event it was. So either, in this case, there's only one action, which is I was pressed on. It gets the source of the object, and then based on what the object was, it does certain things. Okay, that's GUI at like a high level overview. I would highly recommend going into, you can download this yourself. I would highly recommend going in and playing around with the GUI just because it can be very confusing at first. But once it's kind of fun once you get the hang of it because you can just add components and do things. Okay, where were we? Okay, like we talked about, variables can be declared, and now we are going into instance variables. Places where variables can be, they can be local variables in method bodies, formal parameters in method headers. But you can also have variables in fields or in classes. So in this class, we had a bunch of variables for the input text, the output text, and then the two models. Those were instance variables of the demo GUI1 class. They're essentially global variables that are shared and can be accessed from all instance methods in the class. So when we call this dot input text or this dot output, we are referencing the input text and output variables. Okay, and because we can't go a class without drawing some nice triangles, this is what the demo GUI constructor does. So we start with this, which has a reference to a demo GUI class. Within that class, it has the reset button, the copy button, and all the other widgets as reference types to those specific classes. So it has a reference to the reset button. It has a reference to the copy button. Before registration of this as an observer of the buttons. So this is, I'll actually pull up the exact line of code where it does this. Okay, so we're like right here. We are here. This is before we call these. We just have references to reset button and copy button. We don't care about what's in them. But what we're doing is we're registering this as an observer of the buttons. So we're saying, hey, oh, that's not it. Go to the reset button that is contained within the demo GUI class. So that is this guy right here. Call the method add action listener and then pass this as an argument. And what that does is it goes to the reset button and it contains a circular reference to this as an action listener, setting up this as an observer of the reset button. So that's what those two lines of code do right there. Okay, Now we're going to talk about how we go from calling a singular line of code, new demo GUI, into this, which is something on your screen, intangible that you could interact with. When demo GUI is executed, demo GUI.main starts execution. The only thing that's called is the constructor for demo GUI. It's called by main. It does all of this code that we walked through, and then it returns to main. So shouldn't the program just finish executing? Well, yes, but that's where threads come in. We talked a little bit about threads. I'm going to delete this. But we talked a little bit about threads. Most notably, it's when we were talking about what happens in Java's memory and Java's runtime execution when you call methods from other methods or when you call methods from main, and so on and so forth. So the main reason, or the main way that we've been talking about methods is, or threads, is through something like this, where you have your main thread, and then let's say you have a method called foo. Let's say foo calls a method called foo2. Here's what will happen. In your main method, you have a thread of execution, which is just, oh, and then here's time. Okay. All right, so when you run your main program, your thread of execution starts on main, and then let's say sometime in main, you call the foo method. It pauses the execution of main, switches the thread of execution to foo, and then foo can continue on doing what foo does. Let's say foo calls foo2 here. Now foo2 will run. It'll do whatever it needs to do. Let's say that foo2 is just a void method. It doesn't do anything. So when that happens, it switches execution back to foo. Foo, let's say, does a bunch of other things. Let's say it calls foo2 again. Foo2 again will start a new thread of execution. It'll end. We'll go back to foo. Let's say it's done there. And then finally, it'll go back to me. Threads of execution are a way of essentially looking at which method or who has control of Java's resources at the current point. So in any of these points, you can see that one method or another has control of Java. Okay, standard Java program executes in a thread, i.e. a single path of sequential code executing one step at a time. Sometimes you'll hear about multi-threaded programming, and that's essentially if, say we wanted to call foo 100 times, but we wanted them to run in parallel instead of having to run foo once, and then once it's done, run foo again. You can actually do things where you do 100 different threads of foo at the same time and then correlate their results. That's systems 1 and 2. Very interesting, very difficult thing to do, but we'll focus simply on single-threaded execution. Single path of sequential code executing one step at a time. Oh, I guess we'll talk about it now. A GUI program with Swing uses at least 2 threads rather than 1. So you have the initial thread, which executes main until it completes, and then what's known as an event dispatch thread, which executes everything else. An event dispatch thread essentially sets up the GUI and then says, hey, run until the user clears an exit event, which should kill this thread. And then anytime that an action happens, you should give over execution to some method that will take care of what event has happened. Okay, here's a more formal drawing, but you have main. The initial thread or main executes until it calls demo GUI constructor, which executes until it calls the JFrame constructor super, which starts Swing code executing in the event dispatch thread. And the demo GUI constructor continues until it returns to main. But since the Swing code is the only line of code that we had, it is the end of the initial thread. And then the Swing code is the only thing that continues on. So essentially with GUI code, the entire point of main is to dispatch the Swing code. And then the Swing code can run for as long as, well, I don't have an instance of it running right now, but when I run it, you'll see. Normally, when you have a program, it stops when, say, it's done running, or if it's waiting for user input. This will run until I click the red button. So I could leave it up here for eons and millennia, and Java would still be waiting for something to happen. That's what this Swing code is this thread of execution. When you do something that results in a call to action performed, remember this code down here, which processes the events. It goes to another thread of execution, which isn't shown, but when it returns, the Swing code resumes and so on. Okay, that's how threads work at a very basic level. essentially all you need to know is that this code that we're running right here is not in the main program. It is a separate thread of execution. Okay, layout managers allow you to arrange widgets without providing specific location coordinates. So this is when we went into the grid layout and we saw that it was just rows and columns. There's flow layout, which is the default for JPanel, which I think just adds things over and over again until it runs out of space. And then border layout, which I don't think I don't even know what it is. So you guys definitely don't need to know what it is, I don't think. Okay, here are some important packages. These are simply the packages which define all of the code that you don't have to write, which is nice. And then there's a bunch of widgets that you can check. So you can have a checkbox, a combo box, a text area. These are fun to explore if you want to take the demo GUI code. If you're really jazzed about GUI, you can change a bunch of the components to be a bunch of other things, such as text box, combo boxes. I'm assuming if you look up Java. Actually, you know what? Let's do it. If you look up javax.swing components, I'm sure there's like thousands. Yeah. So these are all the things that you can add. What's a radio button? Wait. You could get lost in the API. I'm gonna look up what a radio button is because I'm kind of confused. What is a radio button? You are a male. Okay. Oh, I assume it's okay. Okay, I think it's just a multiple choice button, but it's called a radio button. But yeah, you can get lost in there. You could play around with the GUI if you want to. There's a bunch of widgets. That's it. Any questions about GUIs? Okay. Well, Thursday we'll talk about it more, and then Tuesday we'll talk about it more, and then Thursday we'll talk about it more. But yeah, that's that. Yeah. Yes, I do have them. Zoe, right?
Well,
Zoe?
Jessica.
Sorry.
No, you're fine.
Sometimes I don't even know.
You're fine. Thank you.
Yeah, have a good one. Yes.
Good question.
Yeah.
Is aliasing allowed in our projects?
Aliasing? Yes, but only like what's it called? Dangerous aliasing. So if you're storing like natural numbers
Okay.
or like mutable types, probably not, no.
Okay, so you can use alias those.
Yes. Or if you're using like a for each loop,
Okay, got it.
that kind of stuff.
Thanks.
Sending into project
Through email, I saw it, yeah.
Okay, just under.
Yeah, I have a midterm today, but I probably won't get it until tomorrow.
That's fine.
And if it's not graded by tomorrow night, then just send me a Slack message because I probably just forgot. Thank you.